Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. I am Dr. Nasir Rehman, Assistant Professor, Department of Mathematics and Statistics, Allama Iqbal Open University, Islamabad. Today we are going to start the series of lectures for your calculus course of BS Computer Science program. As you know that mathematics is the mother of all the sciences, so it has fundamental importance for the better understanding of all the science subjects. Mathematics develops logic, and logic is basic ingredient and requirement for your computer science subjects. With a sound background of mathematics, especially basic calculus, linear algebra, discrete mathematics, and optimization theory, you will be very easily and smoothly understand your computer courses. Calculus is one of the supreme creations of human thought. It combines analytical and geometric ideas to forego powerful tools for the solution of important problems and to develop concepts of central importance in mathematics. We will discuss today and try to explore the following topics in our first lecture. Number 1, history of calculus. Number 2, differential calculus. Number 3, integral calculus. Number 4, achievements of different scientists in the field of calculus. And number 5, applications of calculus. So first of all, we will start that what is calculus. Calculus is the most important branch of mathematics. Calculus is the mathematical tool used to analyze the change in physical quantities. Calculus is actually the mathematics of motion and change. First, we will see what is calculus and why we need this calculus. What are the basic questions that we will explore? What are the roots of calculus? Where it has been used in past? What are the applications of calculus? Who were the scientists played vital role in the development of calculus? What were the problems for which calculus was developed? Some of the mathematical and practical problems which we face in our life are: find tangent line to a curve at a point, find the length of a curve, area of a region, volume of a solid, find the maximum and minimum values of quantities, find velocity and acceleration of a body at any instant. Dear students, now we will see how to draw the tangent line to some given shapes. First of all, we see the shape of a circle. Now, how many tangent lines can we draw on this circle? As you can see that the tangent line cuts the circle only at one point, so we can draw infinitely many lines on this circle. Now we come to the second diagram. Here you can see the diagram of a hyperbola, and in this hyperbola you can see two straight lines. Y is equal to b over ax, and second one is y is equal to minus b over ax. So these two are the tangent lines on this hyperbola. Next we come to the third shape, which is the ellipse. So for this ellipse we can also draw infinitely many tangent lines, but you can see that at the points minus 2, 0 and 2, 0 the tangent line will be vertical, and at the point 0, 1 and 0, minus 1 the tangent lines are horizontal. Dear students, shapes are very important in calculus. Now we will see how to find the length, area and volume of different shapes. We can see the shape of a triangle, a rectangle, a square, circle, etc. Now how to find the length of these shapes, the area of these regions and the volumes of some solids. Dear students, we can use calculus to find the maximum and minimum values of some quantities. For examples, maximum and minimum distances of a planet from the sun at what time the earth will be closest to the sun or at what time it will be farthest from the sun. And similarly, maximum range suitable for a projectile by varying its angle of fire. So, how can we get the maximum range and how can we get the minimum range? Dear students, motion of an object is very important, and to discuss the motion of an object, we can see velocities and accelerations every day in our life, and now we will see how to find the velocity and acceleration of a moving particle. Dear students, in this shape, velocity is given by the change in distance divided by the change in time. And then the change in velocity gives us the acceleration, and for this acceleration formula is given here. Then the acceleration is equal to change in velocity divided by change in time. Calculus is basically of two types, and we will explore both the types. First one is the differential calculus and the second one is integral calculus. Differential calculus deals with the problem of calculating rate of change, defines slopes of curves, calculates velocities, calculates acceleration of moving bodies, finds greatest range, predicts times when planets would be closest together or farthest apart. Dear students, in calculus, the notion of derivative is very important. Derivative. Derivative of a function at a certain point describes the behavior of a function near that point. Mathematically, we write dy by dx equal to limit delta x goes to 0 delta y by delta x. This dy by dx gives us the derivative of the function y with respect to x. And here we can see then limit delta x goes to 0 means that the change is very small or the change is approaching 0 when we can see the change in delta y with respect to the change in delta x. Dear students, now I define derivative by using an example. Mathematical definition of derivative. Let us we have a function f of x is equal to x square plus 2. Then for a real valued function of a single variable, the derivative at a point equals the slope of tangent line to the graph of the function at that point. For example, when we draw this function for different values of x, we get the following shape. At x, the value of the function is f of x, and after a small change delta x, we are at x plus delta x, and the value of the function is f of x plus delta x. Now, by joining these 2 points x and delta x, we get this slope of this line, and mathematically the slope is equal to change in y over change in x, which is y2 minus y1 over x2 minus x1. Now, slope is equal to f of x plus delta x minus f of x over x minus x plus delta x, which is the change in x. Now, taking limit when this delta x approaches to 0, in other words, when the value of the function is approaching its value at x, then this limit is given by limit delta x goes to 0, f of x plus delta x minus f of x over delta x, which is the value of the derivative at the point x. Dear students, to calculate the derivative, there are many methods, and the most important and most basic method is using the first principle, or we also call it the ab initio method. First principle of derivative. So, let us we have a function y is equal to f of x. We see a small change in y and we denote it y plus delta y. This is equal to f of x plus delta x. Now, taking y on the other side, we have delta y is equal to f of x plus delta x minus y, or Putting the value of y as f of x, we get delta y is equal to f of x plus delta x minus f of x. Now dividing both sides by delta x, we get the following equality. Now taking limit on both sides of this equality as delta x goes to 0, we get dy by dx is equal to limit delta x goes to 0 f of x plus delta x minus f of x over delta x, which is the limiting value of this derivative, and this is called the first principle or ab initio method. Dear students, now we come to the second type of calculus, which is called integral calculus. This calculus is very important also, and it plays a vital role in some practical problems of our daily life. Integral calculus deals with the problem of determining a function from information about its rate of change, enables us to calculate future location of a body from its present position and knowledge of forces acting on it, enables us to find the area of irregular regions in the plane, enables us to measure the length of curves. Curves can be parabola, ellipse, hyperbola, enables us to find the volume of arbitrary solids. Dear students, there are two types of integrals. First one is the definite integral. Here we are given the upper and lower limits, and the second one is the indefinite integral, where we do not know the limits of that integral. First we define what is indefinite integral. Let f of x be a given function. If there is a differentiable function f of x, then expression f of x plus c is called indefinite integral and denoted by the integral f of x dx equal to f of x plus c. In this equality, the following symbols are very important. The first one is the integral sign. Next, f of x is the integrand to which we are going to integrate. X is the variable of integration with respect to which we are going to integrate, and c is the constant of integration. Dear students, the second one is definite integral. Here we are given the limits, and there are two basic ways to calculate the definite integral. The first one is we use the limit of sums to find the definite integral, and the second one is we can use area diagram to calculate the definite integral. First we will see how to find the definite integral using the area. Let a function f be continuous on the interval x0 to xn. The area of the region bounded by the graph of the function y is equal to f of x, the x-axis, and ordinates x is equal to x0 and x is equal to xn is given in this diagram. So here we, on the x-axis, we divide the points from x0 to xn, and the function is given here. So the area under this function f of x is given by the integral from x0 to xn f of x dx. Dear students, now I am going to state the most important theorem of calculus, which is called the fundamental theorem of calculus, and it has many applications. Fundamental theorem of calculus. If a function f is continuous on closed interval ab and there is a differentiable function f on closed interval ab such that f prime of x is equal to f of x, then the integral from a to b f of x dx is equal to f of b minus f of a. This is called the integral form of the fundamental theorem of calculus. Dear students, calculus was developed in the 17th century, and now it's very necessary to talk about the personalities who developed calculus at that time, and there are two big names in calculus. The first one is Isaac Newton and the second one is Leibniz. So we will talk about these personalities one by one. Isaac Newton was born in 1642. He was an Englishman and he did a lot of work for the calculus. Actually, he invented calculus. Today we are using that calculus. Isaac Newton discovered calculus, recognized the underlying principles of planetary motion and gravity, determined that white sunlight was composed of all colors, formulated the law of gravitation and used it to explain the motion of moon, planets and tides. Formulated basic theories of light, thermodynamics and hydrodynamics. Devised and constructed the first modern reflecting telescope. Formulated basic laws of motion, which are fundamental laws in physics and engineering. Dear students, the second big name is Leibniz. Leibniz was born in 1646 in the same age as that was for Isaac Newton. He did a lot of work for calculus separately from the Newton, and he was a German scientist. Dear students, when we study calculus, it is very important to see the applications, and now we are going to state some of the important applications of calculus. Applications of calculus. Satellite orbits. The communication satellite is placed into a circular orbit around the Earth. The shape and size of its orbit depends upon its energy. The energy with which it was injected into orbit. Also, it should have a definite altitude about Earth and it must move with a definite speed. This speed and altitude are determined with the help of calculus following the basic laws of Newton. Dear students, as you know, we have energy crises throughout the world, and calculus tells us how to maximize our sources of energy using this important subject. Energy projects. A power tower produces electricity directly from sunlight by focusing thousands of sun tracking mirrors on a single receiver sitting on the top of the tower. The thermal energy of sun stores it in tanks of molten salt at temperatures greater than 500 degrees centigrade. When electricity is needed, energy is used to create steam, which devises a conventional electricity generating turbine. Calculus is used to maximize the efficiency of this process. We can see the applications of calculus in nature also. For example, structure of rainbow. Here we can see different colors. For example, when the light beam comes on a prism, it is divided into 7 colors, which are red, orange, yellow, green, blue, indigo and violet. This deflection of light into 7 colors is explained with the help of calculus. Dear students, we can see the applications of calculus in business also. Profit and cost function. We have the function c of x equal to 3000 plus 10x plus 0.1 x square, which we denote by cost function. Then the first derivative of this function putting equal to 0 gives us the extreme values, and then taking the second derivative greater than 0 gives us the minimum cost. Similarly, if we have the profit function, which we denote by pi of x given by 200 plus 10x plus 0.5 x square. Similarly, if we make the first derivative equal to 0 gives us some extreme points, and then if its second derivative is negative, then we have the maximum profit. Dear students, I have mentioned here only a few applications of calculus. There are many other modern day applications which have very powerful impact in different fields, like number 1, investigating the rate of growth of population, predicting the outcome of chemical reactions, measuring instantaneous changes in electric current, forecasting economic profits and losses, determining the spread of epidemics, etc. We have discussed today history of calculus, differential calculus, integral calculus, achievements of different scientists in solving problems, and applications of calculus. Dear students, that's all for the today program. I hope you have enjoyed today's lecture, and we will continue this series of lectures for you. Thanks.